I'm here to talk about Kitware's journey in the open source sustainability field. And I'll start with VTK and CMake, and we'll do a little walk down memory lane. So a little about me. I've got a really short, boring resume. I've had 2 jobs in a professional career. So from 1990 to 1999, I was at GE's Corporate Research and Development Center up in upstate New York, and I worked in a computer vision group there. I was fresh out of college with a bachelor's degree, and they paid for my master's degree at RPI, and I got up there and was all excited about this shiny new C++ language, and I helped that group move off of Symbolic's list machines to C++ using Cfront at the time. Anybody else in here ever use a Symbolic's list machine? They were kind of cool, weren't they? It was like a hardware around Emacs. Anyways, but I was sort of the software and build guy. It was sort of a preservation of sanity. My boss loved to do demos, and we'd do a demo for some customer, and then 2 weeks later, he would come in the office and say, hey, a new customer's coming by tomorrow. I want to show that demo we did last week. And I go, sure. And I go try to run it. And of course, the PhDs in the room had completely broken the code, and nothing worked. So I was very interested in coming up with ideas of how to keep that stuff working. And I set up all kinds of cron jobs to do builds, and I would email them when they failed, and this is before CI/CD. This is 1990, right? Then I was there for like 9 years, and in '98 I helped found Kitware. I started the CMake project in 1999. I'm mostly management now, pointy-haired boss stuff, finding funding for CMake and keeping Kitware running. And speaking of running, I also like to run. That's a picture of me running the Leadville 100-mile race. So let's go back to 1994. The Sony PlayStation came out. And Netscape navigation. And here was the compiler set for C++. Borland was a big one, Microsoft, Wacom, the Sun Pro set. Also in 1994, VTK hit the world. This was a software that came along with a textbook, and it was created by these 3 folks at GE, Will Schroeder, Bill Lorenzen, and Ken Martin. GE loved to have authors in their employ at the research center. I remember in the lobby they had a glass case with a bunch of books with from various people that worked in the lab that wrote books, but obviously they wouldn't pay people to write books because who could afford that? But they did give them permission to write their own book on their own time using GE equipment, and that they would own the sample software that went along with that book. And they released that under a very permissive BSD license, which became VTK. So that was 94, and then in 1998, this came out. Anybody ever heard of Google? Yeah. And also in 1998, Kitware came out. Notice we really wanted to make sure that we weren't scaring people away. Don't panic, VTK is not going commercial. Open source software was a relatively new thing back at this time, and people were very wary about it, and afraid someone was going to come and turn it into commercial. I suppose those fears are still around today, and that's why we have the foundations to support the software. But I'm going to give this perspective from what Kitware did. So there were 5 of us that worked at GE Research, and originally the idea for the company is we were going to be a software company. What does a software company do? Well, you sell software. So we were going to create licensed software on top of VTK and sell that to the world, and we were going to make tons of money. It was going to be great. But it turned out we really sucked at selling licensed software. We had absolutely zero experience doing such things. But in retrospect, it should have been pretty clear because the 5 of us had 50 plus years experience working in a research lab, doing government grants, doing collaborative work with other companies, building open source software, working on cutting edge stuff, communicating with communities around the world, and shockingly, that's what Kitware ended up turning into. One of the earliest projects we had, sort of 2 things here so we had the Insight Toolkit, and Kitware was part of this team to develop this, mainly because of our experience with VTK. And this was an effort by the National Library of Medicine. And around the same time VTK came out, they came out with this data set, the Visible Human data set. And this data set had a man and woman that donated their bodies to science. And after they deceased, they were frozen solid and sliced thin, and pictures were taken. But before they cut them up, they did CT and MR, and then created this sort of reference data set for people working on medical data. But quickly they realized that it wasn't just the data. If they really wanted to advance the state of the art in segmentation and registration of medical data, they needed to solidify the research into a library. So they wanted to create this C++ library that would be code for the latest and greatest in segmentation and registration. So along the way, we became one of 3 commercial companies and our 3 universities, and we were just tasked with making sure ITK built on all the platforms, not necessarily tasked with writing a new build system for C++, but that's what I did, because why not? We had some funding, and the world needed something like that. Since then, CMake's gotten funding from many projects and other outside contributions. Also, around that same time, Los Alamos National Laboratories reached out to some folks at Kitware because they were using VTK and they thought it was really cool. But the problem with it was it didn't work on their supercomputers. It didn't work on HPC. So they hired Kitware to add MPI support to VTK. And eventually this led to the PairView project, which was to create an end user interface and to provide a visualization tool that researchers could use, and that it was open source and it could work with really large data sets and do data analysis and visualization. And this kind of leads to this realization that I've had over the years that really software now is the language of science. I mean, I guess in the past it was mathematics, but that mathematics has to be encoded in software. And we're big proponents at Kitware of open science. And what we mean by that is that you have open access to the science along with open source to get access to the algorithms behind the science and open data and a community around that. And this isn't anything new. In the 1600s, the Royal Society, they were real militant about this. If it's not reproducible, it's not science. So the world learned from this, right? Well, 300 years later, this in Nature article came out in 2012, finding that a whole bunch of papers published in science journals describing landmark breakthroughs were actually not reproducible. Thus, kind of wrong. So software has really become the foundation of the world we live in. Going back to my running rant, so they got these really great, amazing GPS watches, sort of a miracle of modern science. But if you dig deep enough in the menus, you can see there's various open source licenses, even in my watch. You can see it uses curl, boring SSL, and a lot of these packages are the same things that we build our scientific software on. So that the world and open source software increasingly relies on software. The throwaway mentality is no longer viable for large, complex software systems. I can remember when I first got to the research center, a lot of the researchers, they'd like to write their code, prove their thing, write their paper, and then throw it away, which made repeating demos really difficult, which made wanting to build these software systems really important. And I think one of the reasons that the software that we developed over the years at Kitware is still around today and relevant is the process around that software. And this, again, was before there was a lot of this available. But the gist of it is that the software developers write their code, they check it in somewhere or put it available somewhere, and then there's some sort of automated testing that happens, and then the results are fed back to those developers, and there's this feedback loop of constant review and test that makes the software sustainable. And we originally, this came out of a project at GE Research. It was a Six Sigma effort that Jack Welch put out, which was, he tried to apply that across the whole company. Everybody had to take Six Sigma classes. And one of the things the software folks at the research center were like, well, what can we do that's measurable in software? So came up with the concept of a dashboard. And what can we measure? Like, well, you can measure how many tests are passing or failing. You can measure how many build errors or warnings there are. And this became like a really great way, and we've got this open source website that SPAC uses it, a lot of projects here use it, but it was something originally came out of the VTK project. You can search for results, so if I want to find all the sites that called Microsoft, I can find those. I can compare results across systems, so I can look at a test and see how it's performing across different systems. I can track the health over time of the software through this one dashboard, and this can integrate in with GitHub Actions or other GitLab CI testing. And it provides like a much better interface. Like a lot of times these CI systems, oh, it failed. Click here, and then you get 10,000 lines of output from the build, and something failed in there. Whereas this breaks it down into individual failed tests and errors and warnings. You can track test timing to see if tests have started taking longer. You can do, well, Trilinos uses this, multi-package dashboard. So there's Trilinos project, which has sub-projects. You can do code coverage in here and provide visibility for that. Another tool we developed here at Kitware was Ghostflow, which is Git-hosted workflow. It's a Rust-based tool to manage Git workflows used in CMake, VTK, and ParaView. Encourage you to look it up later after this talk. But I think that the point of it is that we've always, at Kitware, had a very strong relationship with software process and making that easier, right? I think, so like if we go back to code coverage or maybe something like Valgrind, not many developers may know how to run code coverage, right? It's kind of tricky. You have to add a bunch of weird command line options. You have to use the right compiler and things. But all the developers know how to look at a web page. So if you can create tools that run the tools to help the developers, that's an important part in creating sustainable software. So all this open source software and development, how does Kitware stay in business? So over the years, basically our business model has become the people, right? We provide talented people to do really cool things for companies. I like to say we're selling what we will do for you instead of selling what we did last year. So how does an open source business model work? Giving away stuff and making money always confuses people. There's some really good analogies though, I think, in the, say, a legal service. The law is free and open for anybody to read, but you probably wouldn't want to defend yourself should you have to go to court or need a lawyer. You would hire a lawyer, an expert that understands this complex system. Similarly with the tax services. Maybe you can get some software to do it for you, but a lot of times you need an accountant to do your taxes. But the tax law and stuff is completely free and open. So servicing a complex knowledge base that might have millions of lines of code, complex computations, can require years of training and experience and expertise in building this. So providing support, fixing bugs, providing help, customizing software, providing books and resources, technology integration, taking open source technologies into enterprise workflows, requires continual innovation stream, and we collaborate on research and development, building this open source infrastructure that the rest of the world can use. But then people might say, oh, I'm not going to work with Kitware because they're going to make all my stuff open source. No, we understand customers have reasons for doing proprietary software, and we often build proprietary software for companies on top of these open source platforms. We will encourage people to contribute back to the open source whenever possible. This allows them to reap the benefits of open source. So if we add some feature into PeerView, and it's not key to what they're selling, but it's important, we try to make the argument that, well, once it gets into VTK or PeerView, then you don't have to maintain it anymore. It's going to get maintained by that whole open source infrastructure that I was talking about and tested nightly. And basically the community, therefore, will then support it into the future. Whereas if you fork it and have your own version of something, then you're going to have to constantly maintain it yourself. And if you do upgrades, you may miss out and make it harder for you to do upgrades. And we also work with export controlled and security protected groups in the Department of Defense and other agencies where we can't release everything as open source. Although often the real concern is the data there and not the software. And permission is frequently given to release it, although sometimes not in the rapid deployment that you'd expect in the open source world. I asked my AI slide here. I've been wanting to build this slide, but I think it just did do a pretty good job of capturing it, even though the logos and stuff are all garbage and it's weird AI looking stuff. But the sense here is that what Kitware has come to be is like this nexus for providing support for these open source platforms. And we're able to pull in government funding, commercial funding, community contributions, and reaching out and building this community that funnels into these software packages and gives them a longer life and brings together groups across time periods or coincident to each other, and it provides a much stabler thing. But it's not easy, and it's tough to develop software this way. Oftentimes people are like, what's your roadmap for CMake? Like, well, I have thoughts, I have things I want to do, but it's going to depend on where I can find either community contributions or interested companies or government agencies that are interested in adding these features into the project, and then find that funding and then bring it in. But we're able to keep these packages alive for 25 years, which is just mind-boggling. It also kind of think about that, like the software you write today may be around 25 years later. So do a good job. We also, it's not just software invented here at Kitware. We've been part of the SPAC project for many years, working with Todd and the labs. Everybody knows what SPAC is, but we added Windows support for it at Kitware. Any hoots or hollers on that one? All right, good. That's awesome. No, I think it's really important because I really want to see a future where package management for C++ is kind of a solved thing, and it's got to be cross-platform if that's going to happen. I mean, eventually someday you want an ecosystem where I can just say, you know, build this software, build all its dependencies, and it just works, and it works everywhere that the software works. And along those lines, you know, we've helped with Spec CI, doing millions of builds across thousands of packages. And then, you know, this was an inside Kitware, a collaboration between our data analytics team, our software process team, and our scientific computing team. We've built up this infrastructure, working on, you know, various cloud infrastructure, spinning up using Kubernetes, on average running, you know, 400 plus pods. So, in addition to that, you know, where's Kitware today? Well, this is sort of our marketing slide here, but you know, we do software development. We have several hundred employees. We have a highly trained staff, and we've sort of sustained growth over the years. We're spread out kind of around the world. We have our Clifton Park headquarters. We have Arlington, Virginia, Carbondale, North Carolina, Santa Fe, New Mexico, Minneapolis, and then a subsidiary in Lyon, France. And we work with plenty of academic institutions, government agencies, commercial companies in the medical, energy, and intelligence fields. So again, this kind of goes back to that other slide where we're able to bring forth a large community that may not have worked together or even wanted to work together, but they end up working together on these open source projects, building this infrastructure that's, you know, putting the magic in these watches that can track your running around the world, or, you know, building the next frontiers in science. And we're creating, you know, applications that are across web, desktop, mobile, cloud, and HPC. We've grown lots of other platforms that we try to maintain and grow in the same way. And over the years, we've grown, you know, we started as a visualization company. We added a computer vision group, which kind of almost ate the company. It's about half the company does computer vision and AI and machine learning these days. We had the scientific computing group, which a lot of this group would be familiar with. And then the software and data and engineering group, supporting CMake and web applications with large data, and our medical and biomedical systems group. And now we're exploring foundations in Kitware. We're part of HPSF, one of the member companies, and I'm really looking forward to seeing where this leads. I mean, it's still new to us, and trying to figure out how foundations and Kitware and our business model and our software tools can all live together, and I'm still figuring that out. So hey, may the source be with you, and I'll open it up for questions.
Hi, Bill. I was curious whether you'd be willing to comment on how much of your funding portfolio is government versus commercial, because, you know, we're getting a lot of pressure from the government to try and diversify and pick up funding from commercial sources.
We're getting a lot of pressure from the government too to diversify. Not directly, but yeah, we're probably about 80% government funded at the moment, and we're trying to increase our commercial reach. We've had that effort going on for the past 5 years. And when the company started, it was sort of 50-50, and then the government side grew faster than the commercial side. And then we had experts that were good at going after the government funding, so we're trying to build that back up due to the chaos.
And then also, I appreciated the technical commentary in the talk, but I'm also interested in the boring part of like how you actually got started. So was it like SBIRs or you know, what sort of gave you the initial funding that'll enabled you to grow into what Kitware is today?
Sure. We won an SBIR, phase 1 for uncertainty visualization, and Will Schroeder left GE to work on that project, and didn't even go to phase 2, and then we didn't win any SBIRs for quite a few years after that. We'd almost given up on them, but since then, we've gotten lots of SBIR funding. But it's been a mix. We do a lot of DARPA work, NIH work.
But like in the earliest days when you were just getting started.
Like I said, I'd kind of hit on it, right? So we did the NIH work with ITK,
NIH, okay.
and then the LANL work with VTK were the first really big things we worked on.
Thanks.
While I'm working over there, do you want to tell people what SBIR is? Because not everybody knows.
Okay, well, the SBIR is Small Business Innovative Research Grant, and it is currently on pause because Congress couldn't renew it. There was a fight over the SBIR program, and they just made a compromise, and the Senate passed a bill, which will probably go through the House, although apparently the president's not signing any bills right now. So it's actually, it went, it's been around in the government for many, many years, and it's done some amazing things, and they actually let it lapse. No one thought they would, but they did, and it's been off since the beginning of this government fiscal year. Yeah.
Hi, I'm a contractor at the National Weather Service, and in the last maybe 5-ish years, we pretty much did one big push to get everything to CMake, so all of our libraries and model components are pretty much all CMake, and that's been really great. I'd love to get any insight you have on facilitating or encouraging adoption, especially when it comes to our external collaborators, because we still have, there's always those oddball external libraries where they have an old Makefile and bash script, kind of Frankenstein of a build system, and we'd love to either get some of those codes over to a CMake-based build, or at least kind of facilitate integration so there's less special handling. So any thoughts you have on the technical or the human side of that and facilitating adoption would be greatly appreciated.
Yeah, I mean, just depending on, I don't know, you can't make people do things, but you can provide it, you can write it, you talk to them first and find out if they're interested. Maybe they just don't know how to do it. And if it's small enough, maybe you do it for them and show them how great it is, that it works on all these platforms now. But if they're not going to adopt it at all, then that's kind of a waste of time too. So you definitely want to engage with people and make sure that you're not wasting your time.
So speaking as somebody who is not a CMake expert by any means, the AI tools are a game changer, right? I had to update something. I was moving some files around. I asked the agent, please make me do the CMake updates, and it was that easy. So I think that is game changing for the, I think CMake itself has even more value because more people like me can now do what we need to do without becoming experts.
Yeah, certainly AI is going to change the way we do everything, but.
Can I comment on this?
Yeah, go ahead.
I really hope you have someone else look at it, because CMake has a lot of outdated information out there, and CMake is one of the things where I saw that it was doing sometimes things you definitely shouldn't be doing.
And next month, it will work.
Next month, it will work.
It's not there yet, maybe, but it's future.
Okay.
Yeah, you never know what you're going to get out of it. The problem with AI and CMake is there's a lot of bad CMake out in the world to train the AI. Yeah, it works, sort of, but
Anyways. Let's thank the speaker. We're out of time.